What's up, everybody? So we have a solution STOICH problem now. I have lead nitrate reacting with potassium iodide, and I'm getting lead iodide and potassium nitrate out. So this reaction is what makes that yellow stuff. So when you take a solution, this is aqueous, plus another solution, you get this yellow powder, lead iodide, and that kind of shows you why lead is in paint, because lead makes very bright colors when it reacts with things. So let's take a look at my first question. I have 85 grams of lead iodide being formed. So because this is our solid, my solid has an amount in grams, and I want to know the concentration of lead nitrate that was used if I use 20 milliliters. So there's a lot of information here. I start with grams. Anytime it gives me a gram value, I'm just going to start there. So let's start with 85 grams. So I have 85 grams of lead nitrate. That's what I'm starting with. And I'm going to multiply that by 1 mole over. So basically divide by molar mass. I'm dividing by the molar mass of 331.2 grams per mole. I do need you to know how to get a molar mass. Once you are at moles, then you have to deal with molarity. So let's get our moles first. We're going to do 85 divided by 331.2. And I get about 0.26 moles. That's the amount you have in moles. So step one is to get the grams to moles. Once you have moles, you're going to plug it into the molarity equation. So what's molarity? It's moles over liters, moles over volume. So I have 20 milliliters. That's here. So if I have 0.26 moles in 20 milliliters, then I can easily get my molarity. Molarity is moles over liters. So I have 0.26 moles over, and be careful here, it has to be in liters, 0.02 liters. So we're going to take your mole value, divide by 0.02, and I'm getting about 12.8 molar, which is very, very concentrated. So 12.8, capital M is my unit for molarity. There you go. My second problem deals with a little bit different stuff. So it deals with concentration, but I have two concentrations. So I got my molarity of the first one. It has nothing to do with my second problem. My second problem says 50 milliliters of 3 molars of Ki, a lot of info here, fully reacts with, okay, this is important, fully reacts with means the moles of one reactant equal the moles of the other reactant if my mole ratio is 1 to 1. So fully reacts with what volume of 0.6 molar lead nitrate? Okay. Anytime I'm given two concentrations, I got to set up my C1V1 equals C2V2 equation. Concentration 1 times volume 1 equals concentration 2 times volume 2. You might have seen it as M1V1 equals M2V2. Either one works. The problem is this mole ratio might not be 1 to 1, so let's take a look. Ki here has a 2 out front. Uh-oh. And lead nitrate has a 1 out front. So that means I have to divide the Ki information by 2 to get my ratio down to 1 to 1. Otherwise, this equation doesn't work. So what I'm going to do is make this over coefficient 1, and this one over coefficient 2. And now you just assign your chemicals 1s and 2s. So let's start with my first information, 50 milliliters of 3 molar Ki. So let's make Ki our first chemical. So I have 50 milliliters of 3 molars. Now, I can keep this in milliliters because it's C1V1 equals C2V2. So concentration 1 is 3, volume 1 is 50, over my coefficient 1, which is 2. Now again, why do I use this equation? It's because I'm given two concentrations. If I'm given two concentrations or two volumes, I have to use this equation. So 3 times 50 over 2 equals, my other side, C2 is 0.6 given in the problem, V2 we don't know, and my coefficient is 1, so I'm going to just put that over 1, which is really nice. So let's solve. All you have to do is do the math on the left and then divide by 0.6. So let's do it. 3 times 50 is 150. Divided by 2 is 75. 75 divided by 0.6 gives me a final volume of 125 milliliters. And you're done. If the question asks you in liters, you can change it at the end. That works as well. Good luck on the test.